For this video, we're looking at proof by contradiction. And in particular, we're going to start off with some relatively nice examples about odds and evens and so on. So, proof by contradiction that the sum of an even number and an odd number cannot be even. The first thing we're always going to do on these is we're going to write assume or pretend or suppose. If you don't do that, you will just be dropping the marks because it's part of the argument of proof by contradiction. So what we're going to assume? Well, we're going to assume, we're going to take this argument here, and the way that we kind of need to think of it, so sometimes it's obvious what to do, sometimes it's less obvious, but try and look at most arguments if you're not sure like this. So I'm going to say, let's rephrase this. I'm going to say if A, then B. Okay, if you're not quite sure how to get started. So what do I mean? So the sum of an even and an odd number. So if A means like if you have an even number and an odd number. Okay, that's kind of like the starting point of the argument. Well, if you have this and you add them together, then cannot be even. Okay? So the way that you kind of structure proof by contradiction questions is you generally write them like this. So you say, assume if you have this, then not that thing. Okay? So if you're unsure about how to write the assumption and get started, I find that sometimes this is useful. So I'm going to use that now. So I'm going to say assume that, and I'm going to copy the language here. So the sum of an even and an odd number can or is even. Okay? So that's how I'm going to write my assumption. And then what I'm going to do is I'm going to sort of get an even number, get an odd number, investigate this, and hopefully kind of break my own assumption. So an even number, well, we're going to call an even number, no, that's an odd one. We're going to call an even number 2k, and we're going to call an odd number, what shall we call it? Let's call it 2m plus 1. Okay, so if I have 2k plus 2m plus 1, well, it's not the most interesting thing in the world, is it? Because it's still 2k plus 2m plus 1. But if I factorize the 2 out, okay, this is an odd sort of number in front of me. So I've got an even plus an odd plus a 1, which equals an odd number. Okay, so what's the problem with this? Well, the problem is that what we've just investigated now, we've shown that this is odd, but over here in our assumption we were saying that it is even. So here is our contradiction. The contradiction takes place inside the argument. Notice that immediately after writing the assumption, I'm kind of just only working with this. I'm not looking at the original question anymore. So now I just need to explain that I've contradicted myself with these parts here in red. Okay, so I just need to write that. So this contradicts our assumption that, I think I can write that the sum is even. Okay, so this is just me saying that these two things don't work here. So this is now where we go back to the original question. So this is where we now sort of are showing that this statement is the correct statement. Okay, so we only work with the original question right at the start and right at the end. Okay, so we conclude that the sum, and again it's a bit repetitive, but this is just securing the marks, the sum of an even and odd, and what did they say? They said cannot be even. Cannot be even. Okay, and if you can kind of remember that general pattern, that's how we do it. That's how we safely secure the marks on this question. So often it's not too bad to work out what to go, how to kind of write your assumption. But if you are finding it confusing, try using that sort of part there in the box. So I'm going to give you a similar one now to have a go at for yourself, which is in front of you now. Okay, so when you were investigating this, your assumption should be that it's not even. If you said odd, that's also fine, isn't it? Because not even means that something is odd, so that would be your assumption. So you should have worked forwards with something, say like 2k plus 1. You should have done 2k plus 1 squared plus 1, 4k squared plus 4k plus 2, and then you want to be factorizing the 2 out. Factorizing the 2 out, specifically a 2, shows you understand that you have an even term in front. So which is even, and then again you would kind of add the cherry on top, which contradicts the assumption. So here's the sort of the neat version of how you can do this. So odds and evens for proof by contradiction, hopefully you're seeing here that they're really not a bad way to get started.